Okay, so my name is Brenda Larcom, and I'm going to talk about Trike, which is a threat modeling methodology that I work on with some other people. I've been doing threat modeling stuff for about 9 years now. I do threat modeling as one of the things that I do for a living. So, and I'm the lead developer and one of the co-founders for Trike. So, I don't know, maybe I know a little bit. And I guess the reason that we developed Trike was we had started doing a couple threat models using Stride, and one of the things that we found was that all the threat models kind of came out exactly the same, and there was a lot of repetition, and it was sort of, it got a little boring after a while. And then also, when I looked at some threat models that other people had created with Stride, they were wildly varying in size and quality both. So one example was an actual desktop application that was a shipping product that had one threat, which I personally think you can tell from just that had to be an inadequate threat model. So basically what we thought we'd do is we thought we'd just start automating a little bit of the repetitive stuff, and then we wouldn't have to do the repetitive stuff, and then we could spend our time doing the actual analysis. And then what I'm about to talk about is what it ended up growing into over the last, that was 2003, so the last 9 years. So basically what we're going to go into, this is just the quick table of contents. The first thing I'm going to talk about is what's different about Trike, so that if you find that you're not interested, you can walk away. And then that'll include what's cool about it and also sort of the disadvantages that it has. We'll go into just enough theory for the presentation to make sense. We'll talk about what should go into a threat model from Trike's perspective, how you would put it together, and then how you would use a Trike threat model, which is actually a bit more useful, in my opinion, than other threat modeling methodologies that I've seen. And then last, I'll go into what tool support is available now and kind of what our plans are for the future. Okay, so the first thing that we did was we automated threat generation, which sounds kind of crazy, but I'll go into more about it. But basically, there's no brainstorming involved at all with Trike. You don't have to try to think up what are the threats. The threats are defined for you. So all you have to do is analyze them, basically. So one of the things that means is that somebody who is a security inexperienced developer can actually use it and reliably find issues. So my experience has been that a security inexperienced person will find about 80% of what I will find. So I think that's pretty good. I certainly haven't been able to get that result with other methodologies that I've tried to use. So another thing is that when you're using it, a security geek can then pick up where the developer left off. So with some of the other ones, you have to kind of start over because it's not, the thought process of the developer isn't really clear, and you kind of have to just do it all over, basically. Another thing is that we tried to make it really clear what needs to be analyzed and what doesn't need to be analyzed, when to stop, that kind of thing. That was one of the problems that we were experiencing and that a lot of people have reported to me is it's kind of this analysis paralysis thing where you put data in, you keep analyzing, and you keep analyzing, and you keep analyzing, and when, what's the end of that? We're using attack chaining rather than attack trees. Attack trees were one of the things that was causing us to do a lot of busy work over and over again, and they were kind of all the same, and we've cut them entirely at this point. The tools that we have are providing immediate feedback as you design rather than sort of postponing and having like a calculate step in them or something like that. We start earlier. We start at requirements time instead of waiting until architecture time. So we're actually analyzing whether the requirements are safe as well as whether the architecture is safe. And another thing is we don't just look at like the static architecture, like the components and how they hook to each other. We also look at the sequences of events, like the algorithms and the steps that are being used. And finally, we include the intended behavior of the system in the model. So it's not just what can the attacker do using stuff that's broken about the system, but what can the attacker do by combining broken stuff and what the system was supposed to do to start with. So that was the cool stuff. So this is the less cool stuff. This is kind of how you pay, basically. So one thing is that the tools and methodology, basically, they kind of hard code some theory stuff. And so if you don't, and we'll get into that on the next slide, but basically if you don't agree with the assumptions that we made or something like that, then this is going to get answers that you aren't going to like because you don't agree with the assumptions. So basically, it's a little bit expert system-y where it sort of hard codes in some knowledge that we had. So, we try to be clear about what the assumptions are so you can make a judgment of whether it's what you want to use. It relies really heavily on automation, so it's not the kind of thing that it's easy to sit down and do like at a whiteboard or something like that. It's pretty hard to do without the tools, and unfortunately all the tools that we have right now are pretty bleeding edge. So, I don't know. Also, it takes more data about the system to do it. No, No, I do not want to accept incoming network connections.
Wiggle your hand at yourself.
What's that? Okay, we're using some different definitions of a lot of common terms that are more restrictive and with kind of a more, I like to think of it as more crisp, but it may be irritating. And also, it's clear when you stop too soon. So one of the side effects that I found of that, especially when working with development teams, is that they're like, what do you mean you can't finish the analysis? I'm like, well, I don't have all of the information. You haven't told me everything that I need to know about the system, so I can't finish the analysis. And they're like, but you haven't finished the analysis. And it's a little, it can be frustrating. So, okay. So this is just enough theory to get you through the rest of this, and then I'll get into what goes into it and what you actually do. So basically, the first thing is that a model is for answering questions. So if you aren't asking any questions, then you are going to end up modeling forever. And that is true for any model system, in my opinion. You can only answer a technical question using a threat model. So all of the stuff about modeling, you know, brand damage and stuff like that, you can't. It's not you. The person who needs to make that connection between brand damage and some technical thing is a business person, possibly with the help of some security person, but in my opinion, it's outside the scope of threat modeling because it can only answer a technical question. If you have a development team, they're going to know a lot about the system, but not necessarily a lot about security. And if you have a security geek, they're going to know a lot about security, but not necessarily a lot about the system. And you need both in order to actually have a good threat model. So that's a little bit of a problem. Secure enough for any particular system is defined to be it meets its security objectives. So you have to set what those security objectives are very carefully because that's the definition that you're going to analyze to in every following step. So it's not this sort of, you know, oh, is this secure enough? Is this not secure enough? It's no longer this sort of matter of judgment. It's you made the decision about what would be secure enough up front, and then you analyze to it and build to it. Attacker goals are not relevant. So the reason they're not relevant is because your mission in life is not to thwart the attacker. Your mission in life is to protect your stuff. So if the attacker wants your stuff that you want to protect, then you want to thwart them. But if they want some other thing that you don't actually care about, don't pour resources into putting it that way because basically you only have a finite amount of money, a finite amount of resources to spend on security. So that's how you should focus it on your own defense goals, not attacker goals. Threats are a function of the system, so they're a function of the system requirements, they're the function of the system architecture, they're a function of the system implementation. They don't just spring up from nowhere. That's why we can generate them instead of you having to brainstorm them, is because they're a direct function of the system. And then also, I kind of alluded to this earlier, but an attacker is not going to stop with just the unintended behavior. They're going to use the intended behavior as well. Okay, so this is what we think goes in the threat model. A lot of it will probably overlap with stuff that you're already putting in threat models, that kind of thing. The things that are different, I think, are the requirement stuff. Sometimes people model deployment environments, sometimes they don't. We consider that to be part of the requirements, even though it's not a functional requirement. The other thing that's different is we've sort of organized it here, as you can see, into the system side and the security side. So you can tell from our discussion earlier about developers versus security people, chances are good that the development team should be providing the information about the system and the security person should be providing the security information. So it's not that overlap is not possible. There can certainly be, you know, people contributing information from the other side, but it's more like it's the authoritative source is one or the other of those things. Okay, so I would love to make this a better diagram. Basically, this is sort of, there are two kind of strains. There's the requirements threat model, and then there's the architecture threat model. So in both cases, there's some development artifact that's in the left-hand column there, and then there's an activity in the middle, which is the threat modeling part of it, and then there's something that you get out of it. And it should affect the little diamond decision that's inside the activity, which is kind of a little loopy there. So basically, when you put in the functional requirements and the deployment environment and you perform a threat modeling process, you get some threats out, you use those to decide on the security objectives, and then you have the security objectives, and that's what you do at requirements time. And then when you move on to architecture, you take the components and the connections and all that kind of stuff and the sequences of events, and you perform another threat modeling process. You get some threats out the side, and at that point, you can get more information like the feasibility and the impact of those threats. Okay, so so this is a screenshot from one of the 2 Trike tools that's out now. This is, in fact, not the one that I actually recommend you use, but basically, the functional requirements, we have you model them basically as a, that's awesome. I've completely forgotten the word. An access control matrix, basically. So this is our intended actions grid, and you would get this normally by talking to the business stakeholder. Like, this wouldn't necessarily be a technical person that you talk to. But you talk to them and you'd be like, okay, what does the system do? And they'd say, well, it does X, Y, and Z. And whatever nouns they mention, chances those are good that those are assets. That's something that they can't describe to you what the purpose of the system is without saying these words, these nouns, whatever they are. So they're not going to talk about passwords, for example. They're probably not going to talk about the database. They're probably not going to talk about that kind of stuff. They're going to be like, I want to, move my trucks from here to there, and so I have a truck routing system, and there's like loads, and people send them like that's the kind of description that you're going to get from a business guy. So that's the kind of thing that would go into the asset column. And then actors, it's old. It's from 2003. So now we would call these favored users, but basically they're the people who are supposed to be using the system. And then it's just a grid. So it's using the taxonomy of CRUD, which is from database land. It's create, read, update, and delete. And this is using this as a taxonomy for every action that is possible on these assets. So this is only true for data assets. And depending on how you talk to, this is a point of theory that you might want to argue with. We found it to be pretty good for the last 9 years, but we did end up having to extend that, so we now actually have 2 additional actions, those being execute and configure, which we had to add to cover mobile code, and also hardware, where you may allocate something and you have to configure it by setting bits or something like that. So okay, so basically this is, from our perspective, the functional requirements. So, and we do actually put in the rules as well. So if it says conditionally, then we would put in what are the actual rules for when this person can do that thing. So can I get a pointer? Hey, look at that, I can get a pointer. So basically, like what this is saying is that an anonymous user can create a user account under some conditions, and we don't know what those are because I didn't print out the screenshot with that. And an admin can always look at a user account. That's basically how you read the code. Okay, so once you've got that in there, and in fact, as you're putting it in, the tool is actually automatically generating threats. So again, this is dependent on theory stuff. So one of the points is you'll notice that there are only 2 things on there, elevation of privilege and denial of service. And we are using those terms much more broadly than people normally do. So elevation of privilege is doing that thing more than they intended. So like this user account here, this one is someone is creating a user account who should not be able to create a user account. And then denial of service would be somebody is trying to create a user account, but the attacker has prevented them from actually being able to do it, even though they should have been able to according to the business rules of the system. So that's pretty much it, because everything that could go wrong from a security perspective, it is, again, our theory, will fall into one of those 2 categories. Either it's going to be more, it's going to be the attacker doing something more than they should, or it's going to be them stopping somebody else from doing something that they wanted to do and should have been able to do. Okay.
Does the tool understand that admin is greater than user and user is greater than anonymous, or are those just labels?
Well, it doesn't. So one thing it does understand is, so it understands which actions each of those people are supposed to do, and it does understand which users are unauthenticated. So in fact, actually, you'll see, so right here, this read blog, this is blacked out. That threat doesn't apply. It's meaningless for this system because an anonymous user is allowed to read the blog. So it's saying an attacker can read the blog is like, of course, duh. So that's as good as it gets right now. And in general, we found, as we've worked with it, that situations like if the admin had a superset of the user's privileges, for example, like they had some admin privileges and then also they had the user's privileges, we would usually model only the admin privileges in the admin column because when you look at the grid, you can do some kind of cross-checking. So you can do stuff like, for example, if there's an asset that's never created, no user creates that asset, you're like, where did this asset come from? You know, how did it get in the system? It's a sign of a missing requirement, so it might be like a missing role or something like that, which is pretty common. So there's a bunch of like cross-checky sort of things you can do, and it's really crazy. Like that grid looks really simple, and it's like the first time you see it, you're like, what, huh? But once you've seen like 4 or 5 of them for different systems, you look at it and you're just like, oh yeah, this asset probably kind of belongs to that user because it's mostly in that column. You know, that column has a lot more dark colors in it, and it's like a visual representation kind of the functional requirements. It's a little weird, but I don't know. Nice unintended consequence. Okay, so, oh right, and there's also the other omission to notice here is that there's no denial of service for updating a blog entry because our original set of rules over here didn't have any user able to update a blog entry. These are basically immutable blog entries, and so consequently, if an attacker prevents someone from updating a blog entry, great, because we were already supposed to be doing that. Okay, so originally, when this grid first gets produced, everything in it is unknown, and you go through it with the business stakeholder and prioritize. Basically, you say, what is the impact of this threat from a business perspective? And we try to make sure that that's like independent as possible of the other threats, because of the attack chaining thing, we're basically going to cover the analysis anyway, and so if you prioritize them all as high when only one of them actually had a high business impact according to your stakeholder, then it's like you're kind of adding some noise, and it's harder for the business stakeholder to think about it. So it's not the end of the world or anything, but it is harder to communicate about. Let's see. Okay, so then once they've added this stuff in, all of these high priority threats are going to get added into a security objective, and a security objective is what is going to be used to control how you prune your analysis for the entire rest of the threat modeling process, hopefully how you design the system like to meet those security objectives. Like everything about your entire development process, in my opinion, that is security related, excuse me. Is there other parts of development? I don't know. So it should all be controlled by this security objective, because this security objective is basically the, and there's more than one of them normally, I just put an example of one. So this is basically the decision by the business folks, the security folks, the devs. All of you should get together and say, this is what we're going to do, this is what we're committed to for how secure this thing is going to be. And the reason you want it is because of the limited resources thing, and also because if you don't have something like that, then different decisions are going to get made in different places, and the overall system will be actually less secure on the axes that you care about, because you sort of evenly distributed your security effort over the whole thing instead of focusing it on what you actually care about. So there's my pitch. Okay, so those attackers, even though so these ones are actually from our system, so some of the favored users are also attackers. You could have attackers that weren't. The thing that's important about the attackers is not their motivation, it's not their skill level, it is what privileges they start with. So privileges are a very central thing in this threat modeling methodology, because it is all about what privileges you started with and what privileges you have in the end after you've used the system. The prohibited threats are the ones that came from this high priority threat grid. And then there's just a bunch of pre-calculated intended response. So the reason this looks like an Excel screenshot is because it is. I've switched over to screenshots from the other tool, which is the one that is more current and implements more of the methodology. Okay, so basically this is kind of a bit generic, so I'll go through really quickly. But in any threat modeling methodology, what you're going to do is you're going to model the system, you're going to identify some threats, you're going to investigate them, you're going to identify mitigations, you're going to decide which mitigations to use, etc. So we kind of just did that at the requirements level. And what makes Trike special is that when we do this at architecture time, we are going to prune after identifying threats before we investigate them, and also when we investigate them before we identify any mitigations. We're going to like stop and not investigate some of the stuff. Okay, so architecture time. So basically there are 3 kind of main things that go into this from Trike's perspective. So one of them is privilege analysis. So this is kind of the most similar to Stride thing that we have. And perhaps because it's similar to Stride, which people already know how to use, and perhaps because it was less interesting, I guess. We're less finished with this. So basically, any component, though, has a set of privileges that are important. So there are some that it has. There are some that it provides to other components. When it provides them, it might revoke some. It might use some privileges, and it might require some privileges in order to implement those privileges that it provides. So that's kind of, from a security perspective, that is the interface of the module for security purposes. So there can be a lot of inconsistencies or issues with that collection of privileges. So for example, there could be a component that is running as root that needs to be running as a user process, and you would find that because you would look in the has column and it would be, you know, yards long, and you'd look in the uses column and it would be this long, and you'd say to yourself, you know, maybe there's a way that we could get something that would be a little closer to the privileges that this thing's actually going to use in the has column. So that's one thing. Another thing, let's see here. Oh yeah, so another one is if you have an attacker and a favored user that are indistinguishable, sometimes you might have that on purpose if you had a favored user that you had also marked as an attacker. But if you had a situation like that when it wasn't deliberate, you'd think to yourself, okay, so how am I going to actually defend against this attacker? Because I cannot tell them from a regular favored user. There has to be something that the user has that the attacker doesn't for me to be able to distinguish them. You know, maybe it's their password, for example, common implementation. But if there's nothing like that, then you know you're in trouble. Let's see here. And then, so there's another one, which is if you know which component enforces a business rule, and this is getting a little bit out of the scope of just looking in that table. If you know which component enforces a business rule, and you can see that the privileges that are used in order to implement the provided privilege are also held by an attacker, the attacker can provide this privilege themselves. It's like they've kind of gone around the interface that you provided. So that's another thing that this should catch. So it's probably automatable. It's kind of still under development. So fortunately, the thing that we have right now, has-up analysis, will actually find most of that stuff, and the stuff that it won't tend to find will tend to be pretty obvious. Like, clearly you shouldn't run stuff as root if it could be running as a user component. Okay, so what has-up analysis is it's from safety engineering. It's kind of a structured process for evaluating variations on a process to see what their consequences are. And some folks in academia had started using this for security purposes. I found a paper on it. I tried it out. It was awesome. So I'm like, okay, let's adopt that because it's a thing of beauty. So it's sort of semi-automatable, and I'll show you the screenshots and everything, and you can play around with the tool yourself later. And then there's the attack chaining part. So but that would be how you connect these things together. So basically, the system overall has two goals. One of them is the favored users have some starting privileges, and they have to get to the intended actions. So through this sort of graph of privilege transitions that is the system. And that must be the case. And you know that's going to be the case because in any development situation, if the functional requirements are not present, the developers will add the functional requirements and make it work. Like even if it's not in the design, they'll be like, oh, they just forgot to specify this part. So you know that part's going to work. The other goal of the system should be to keep the attackers from their starting privileges from getting to the intended actions or the unintended actions that they're not supposed to be able to get to, those being the prohibited threats for the security objectives. So it's kind of this weird thing where you're like trying to let some people through and then stop other people, and they might be the same people in different places and stuff like that. So that's what this attack chaining thing would be good for. So unfortunately, we don't have it all the way implemented. It's definitely automatable. We've figured out one of the problems with it is kind of how do you get the different edges in the graph to match up, and we've got that pretty well licked. There may be some scalability issues and stuff like that, so we'll find out as we do more work. Okay, so this is a sequence of events as we would put it into the threat modeling tool in order to do has-up analysis. So I'm not going to talk any more about those other two things that we have not gotten completely fleshed out. So basically, what this is saying, so this is working on use case number 3, which I don't even remember what it is, but it looks like we're submitting a blog entry. So the user is submitting this blog entry to the web server, and then I just, for the sake of argument, stuck in an antivirus filter to scan the blog entry, and then if it's got a virus, then the web server is going to say, too bad, there's a virus, won't let you post. And if there isn't a virus, then it's going to say, okay, is there, does this user account have permission to post this blog, et cetera. Then it's going to continue through the rest of this use case. So one of the things that actually, that I won't show, but that HasUp analysis will find in this particular use case is that the computation of doing this antivirus scan is actually fairly expensive, and probably it would make a lot more sense to do the cheaper computation of figuring out whether the user has access to post to this blog first, so that you didn't, it's basically a denial of service issue that is present in this use case the way that it's written, because the expensive computation occurs before the cheap computation that could weed out a lot of stuff. So, but basically, this stuff gets filled in. So almost all this stuff is drop-down. So the actor is a drop-down from the actors tab. The object is a drop-down. Condition is not. So, okay, so once you've got this sequence of events, you're going to go through and you're going to vary each step. So this is the beginning of the HasUp analysis part. So basically, you're going to pick some step, and then you're going to pick some element of the step. So the elements you can pick are like an actor, an action, an object, or a condition, which of course is pretty much everything in the step. And then you'll pick a guide word. So this stuff is automatic. So basically, you say, I'm going to vary the actor from the drop-down, and then it, let's go backwards, getting ahead of ourselves. And then you pick the guide word, and it goes and looks up what does the guide word mean in sort of a generic way, and then you figure out what does that mean in this particular case. So you're like, okay, I was submitting a blog entry to the server, and I'm going to say, what if I wasn't really a user? So I wasn't logged in and I submitted a blog entry. Okay, that's one variation. What if I was also an administrator at the same time? I was a user, somehow I had a dual role, or something weird happened and I was a dual role. What if I'm kind of a user, but I'm kind of not? Like maybe someone else was a user and they logged in using this terminal, and they logged out, but the logout didn't quite work right, everything was cleaned off, some kind of thing like that. So that's what you do. You just write it all down in the spreadsheet. So this is part of the thing that lets you, as the security person, look at what a developer's line of thought was, because you can say, okay, they didn't include all the guide words. So there, let's see, what is there? There's no, as well as, part of, other than, more, less, before, after. They don't all mean something for the same set of elements. Like there can be elements that don't mean anything for that guide word. But pretty much those are your choices. So you can see that they've only put 3 of them here. So that could mean that they think that the other ones are meaningless, but you could just run through them in your head real quick and see, do you think they're meaningless as well, or do you think they missed something? So that's how you would kind of pick up where they left off. And they can definitely have more than one meaning too. So like this part of thing right here, it could mean that they just logged out, or it might mean something else, like they have they have a user ID in the URL, but not in the session cookie, or some kind of situation like that, where only one of the pieces of evidence that's supposed to be there for them is present. So if you had a situation like that in your system, you'd want to put that in there. Okay, so once you've got this variation, the next step is to go through and, so the variations are based on, what is the sequence of events. So now is the moment when you've identified some threats, basically, these variations, and now you want to prune them. You want to say, okay, do I need to investigate this any further? And unfortunately, it's a little bit manual right now. I think once we have the attack chaining thing working, which will never happen in Excel, let me tell you. But when we do, I think that we may be able to partially automate this as well. But basically what you do is you look at this variation, you're like, okay, for each of my different security objectives, could this thing actually help an attacker achieve this security objective, this variation? So now I got to go back a little bit here and find my security objective. I don't remember what it was. Poor planning on my part. Okay, so we're trying to post to somebody else's blog, basically, with security objective number 1. The attacker posts to somebody else's blog that they didn't have access to. Okay, so we said said, okay, a user who's not logged in submits a blog entry to the web server. So that would help an attacker if there was somebody who was not logged in. If that actually worked, they submitted a blog entry, then they would have violated the security objective right there. So you know that that would help them. So you say, okay, yes. And in fact, in that use case, there isn't any step that checks to see whether the user is already logged in. Maybe that happened in a different use case, and the information didn't get transferred over, or maybe it's just a bug in the use case, and actually they're really doing the right thing, but they forgot to write it down or something like that, which, either thing could be happening. But basically, these other things here, we're like, okay, a user who's also an admin submits a blog entry. We're like, no, we don't really care about that because it turns out that our security objectives say that admins are out of scope, so we're not going to do any more work on that. Who cares? And then if the attacker submits a blog entry, from somebody who's already logged out, like, okay, we already have some kind of mitigation in place for that, so we're not going to go analyze any further right now, maybe a little later. So based on that, only one of those things is going to go on to the next question, which is, now we know it would help the attacker do something we don't want them to do. Can an attacker actually do that? And in this case, yeah, of course they can send a post. If you're not checking to make sure that they're logged in, then any attacker on the internet can obviously send a post and post to this person's blog. So I don't know, it's an example. So by the time you're done, you would have, I usually have like maybe 300 lines or so in the spreadsheet that say, here's the use case, and here are all the variations of the use case that seemed meaningful, and here are whether they actually worked out. And the reason that it's only 200 or 300 is because I cheat a little bit, and if I've already considered one case earlier, then of course don't reconsider the same case. I mean, just be like, okay, I already considered this case. We're checking to make sure that they're logged in already. Just get over it. So that's what it is. Okay. So basically, now you have a model, is the theory. So in theory, you ought to be using the thing. And this particular slide, this is generic to any threat modeling methodology at all. You should figure out what decision you want to affect. And then you should figure out what information should be informing that decision. And then you should figure out how to get that information out of the model. And that's pretty much the recipe for using a threat model to affect decision making. If you're not doing that, then I sort of feel like if you are not affecting anything with your threat model, if nothing changes because you did the threat model, then I think that it was kind of wasted effort, and maybe you'd be better off not actually doing the threat model. So I'm pretty big on that. So if you were trying to decide whether an application was ready to launch, then you'd say, okay, maybe I have this expense application. Does it meet its security objectives? That, I think, is the ultimate in should the thing launch or not from a security perspective. If it meets its security objectives, ship it. If it does not, I would say do not ship it. Because you have control over both the security objectives and the application. So your choices are, you could make the security objectives less restrictive. That's a completely legitimate option from a business perspective, is to just say, okay, I can't do this thing this time. I'm just going to reduce my security objectives. But if you ship it when it doesn't meet its security objectives, in my opinion, you're kind of lying to yourself and saying, oh, yes, these are my security objectives. Oh, but I don't really care. I don't actually have to do that thing that I said I would do. So I think that if you don't meet them, you should probably not ship it. So what you do to find out is you would say, okay, where do I have an unbroken chain from the attacker starting privileges to the prohibited threat? If I've got one of those, then it violates the security objectives. If I don't, then it doesn't. Great. Okay, so this one is a little bit different. So at design time, you'd be like, okay, my security objectives ought to be met. That would be nice. My defenses should all be protecting against some threat. In my opinion, if there's a defense that is in the system that doesn't protect against any threat that was listed in your security objectives, or any of the lower level architectural threats that would affect that security objective, then I have to question why that defense was in the product to start with. Because it's not actually helping you achieve more security, and you're spending time developing it and whatnot, when you could spend time developing a defense that would actually help meet your security objectives. Okay, and you would, whatever your threats that you want to respond to or whatever, you would just apply some design patterns that's kind of independent of the threat model, really, other than that you have a list of threats now. And then the best design would have either a smaller number of threats, or the threats that it has would be easier to defend against in some way, and that is subjective, unfortunately. So the ideal thing, in my dream in the future, when we have this whole beautiful attack chaining thing, and there's some slides about this up on the Trike website. Basically, if you think of each link that is in that graph as having a time cost, then you should be able to, in fact, combine all of this information from the attack graph and get an actual, the one true number at the end. But it's a little theoretical still. So, but if you did have the answer to that question, you might actually be able to say, this design is better than this one, or this design is less good than this one. Okay, so now this is the most interesting one in my opinion. So I think this is where Trike really shines as compared to other methodologies. Basically, that threat model is now a test plan where you can go and you can look through those columns. So if you have something that you think would help an attacker, and you're like, oh no, it would help them achieve the security objective, but they can't possibly do it, and here's my rationale for why they can't possibly do it. That rationale is a test, or 5 tests, or 20 tests that should go in your test plan, because you just said the security of my system hinges on these protections. If not, the security objectives from my spreadsheet are violated. So in my opinion, you can just run right down that when you're constructing security tests. And this is not to say that you can construct a pen test plan this way, but you can definitely construct a repeatable, automated, like regular old testing QA procedures kind of set of security tests using this. So the other thing that you could do, and this would get a little closer to exploratory testing, would be to say, okay, I said that thing X would not help an attacker violate the security objectives. Let me try doing that thing and seeing if, in fact, it would actually help an attacker or not. Like maybe that assumption is wrong. So that's another list of things to test. And of course, the spreadsheet, I didn't actually show it, but there's a little tracking thing for mitigations. And what mitigation do you think should respond to that? And then, you know, is it in place and that kind of thing. So that's another thing that tests. So pretty much you can, they're already sorted by what type of test it is. You can just look through the threat model and do the tests. So I think that's kind of cool. Okay, so you want to do it right now. So there's 2 tools that are out right now that are on our website. So one of them is Trike version 1, which is in Squeak, and I think we published it in 2005, which gives you some clue of what it might be like. So it auto-generates the threats. It lets you prioritize stuff. It auto-generates attack tree stubs, because back then we were still in the, oh, maybe we'll just automate this, before we realized that it was all kind of glue stuff and we wanted to just get rid of it entirely. But if you're still doing attack trees, you may find it useful because it's got a bunch of stuff in it that's an auto-generated attack tree. You know. The biggest flaw with this tool is that it doesn't have file import or export. If you want stuff in or out, you have to cope with Squeak and write your own little write it at to file thing. So it was kind of a prototype, and we meant to update it, and it's been a while. So, so in the interim, what we've done is we've come up with basically Trike 1.5, which is this spreadsheet, which we just thought, you know, again, it was kind of like we thought we'd just automate a little bit, and now we have this whole methodology that's completely diverged from everything else. We thought we'd just, you know, put some stuff in a spreadsheet so that we had something to give clients when we were performing threat model for them. You know, they'd want to see a little table of stuff, and they might not want to deal with our Squeak tool. So it is the most complicated spreadsheet I or anyone I know has ever seen. So it's a little bit slow, but it'll auto-generate the threats. It will let you prioritize the stuff. It has a field for security objectives, which is much as possible kind of pre-filled for you. It's got the data collection stuff for the privilege analysis that I talked about, but it's not doing the privilege analysis yet because we don't have the theory quite debugged. And then it's got both data collection and the support for doing HAZOP analysis. So it's really fairly full-featured, and I do update it, and I will fix bugs and stuff like that if you send us emails. So there's a link to it on the homepage from the site. You can download it, and I think I'm going to post another update probably next week because I just fixed a bunch of bugs over the weekend. Okay, so the cool thing that we want to do is we want to do Trike v2. So this would have in it pretty much everything that we've talked about. We have some code. We're working with a student right now who is actually doing a threat model of the new Trike using Trike 1.5, which is pretty awesome. And we're kind of using that as an opportunity to sort of get the design ironed out because we haven't had time to work on it is pretty much the reason that it's fallen by the wayside. So in our dream, it's going to be a sketch-based kind of thing. It will actually, someone's asking me earlier, the plan, which I didn't want to put on the slide in case you know, it's a little early in the plan, but the plan is actually peer-to-peer client service sort of thing going on, and so we hope it will be mostly sketch-driven. So you'll basically, it will be as if you were working at a whiteboard is the idea, and you'll kind of sketch in your architecture, sketch in the steps. A lot of those use cases can actually be collected from a sketch as well. If you sort of, you know, you say, okay, it goes here, it goes here, it goes here, it goes here. This thing does this computation. So that's the idea, and then it'll highlight whatever it is that is going wrong, or like missing information or something like that, as you're drawing is the idea. So that part, the feedback immediately as you're drawing is something that's been, or as you're inputting data, has been something that's in all the tools. And we're also, because that's a little weird, and we know it's a little weird, not everyone likes our crazy UI things, we're also going to provide a REST interface. So if you want to do something more normal, you're welcome to do something more normal and then still use our engine in the back end that does all the fancy stuff, calculation for you. And yes, we're going to write files. There will be files this time, really. So I don't know, it's probably not going to be this year. It'll probably be next year before we get it out, but we're working on it. So there you go. And apparently I have talked too fast, because here I am at the thanks slide. So my collaborators for various things that have contributed to this. And I can answer any question. So.
Two things. One, can you repeat questions when asked? Because the audio will only get you in the microphone normally.
Yes, I will repeat questions when asked.
Two, what kind of licensing as far as source licenses and such are you using for the work you're doing?
So this is all MIT license. So do whatever you like with it. That's the license that we like. So the question was about licensing. Yeah. More questions? Stuff I should go into more detail on? Crazy ideas?
I'm asking in IRC as well for the people that are watching.
A lot of questions until you have actually practiced, used the methodology much. It's going to be hard to actually, it's theoretical stuff. But the, I find it's interesting that you're building out like basically doing graph analysis in a spreadsheet. Are you actually doing proper graph analysis, or did you? Are you just manipulating the structures in the spreadsheet itself?
So the question is whether I'm doing actual graph analysis in the spreadsheet, and no, I'm not. That's one of the reasons that we're going to be moving back to Squeak. I mean, the other one being that really I never intended to become an Excel developer. I got to say I'm much more impressed with people who write code in underfunctioned languages at this point, because it's been very exciting. If you unhide some columns and stuff like that, you can see for yourself the agony that is behind that spreadsheet.
You mentioned that earlier in the presentation that it's essentially designed to have a lot of logic and calculations built into it. With the new version of Trike, is that going to be exposed so that you can adjust it to be more applicable to the type of business that you're in?
So the question is whether in the new version you'll be able to adjust kind of the computations and logic to match the business or the application and stuff like that. So I would say the answer is yes. So the way that Squeak applications work, you can always get at the source code from the actual application. So that's the last resort, of course. But there are a lot of things that should be possible just by changing data structures and stuff like that. And I guess it is not clear to me exactly how much of that will have a UI attached to it beyond the regular Squeak debugging tools. But certainly if there's something like, if anybody in the world is using our tool and needs something exposed or something like that, please just send us email. I mean, I do actually fix bugs that people send me and stuff like that. Most of them are stuff that people send to my personal address, but if you send me a bug, I will fix the bug that is in our stuff. So, or feature requests might be a little bit more challenging sometimes, but definitely if it's something like that where you just want something exposed so you can tweak it, I can totally hook you up.
I have no questions for IRC.
Okay. One thing that I forgot to mention is, so as you're looking for more information on this, there's not, the website is not something that we haven't had a lot of time to keep it totally up to date. The thing that I have been updating is the help in the spreadsheet. So there's a help tab, and it goes on and on and on and on. And it is not complete, but it has a whole lot of information in there about the data that's being put in, like what each of the, there's like all these crazy flags and stuff like that that you have to fill out on every single sheet. And so what order you should fill stuff out in, what the flags mean, how you would use the thing to get the information you're looking for, like all that kind of stuff is in the Help tab. And if you have any more questions that are not answered in that, again, send me a mail and I will write something up for you. And I do, you know, periodically I make more improvements to the Help tab also.
Which version of Excel is required?
Oh, that's an excellent question. So I have a Mac, and I'm doing currently most development in 2011, Excel 2011 for Mac. It works. Last we checked, which was, I just did a bunch of refactoring this weekend that haven't been checked, but prior to that, it was working on Excel 2010 for Windows. It doesn't always look as nice on Windows. The colors don't seem to be cross-platform, and it has a lot of conditional formatting, and that stuff doesn't always work right. But it may not look quite right, but it does operate correctly. And it also worked at least until this weekend. I don't know if it's still true on Excel 2008 for Mac. I know it does not work on OpenOffice. I would love to have somebody who's interested in using it on OpenOffice. If you got in touch with me and we could help, like it's enormous, and finding all the bugs is a process that takes a long time. And I would love if somebody wanted to help me with it. I would definitely fix the bugs. So.
Anybody else? Dan?
Cool.
Thank you.
Thanks, guys. Appreciate it.